Hello, students. We have first recorded lesson of the 2017 school year, and we are on page 29, and this is an enrichment or an extension of what's been going on. So at this point, you've had an opportunity to practice and build a little fluency with solving two-step equations. So on page 29, I wanted to take a look at a different type of a two-step equation, and to show you that you don't always add or subtract first. The problems we've been working on, if we consider PEMDAS backwards, okay, usually we're subtracting and adding something first, then we're dividing or multiplying something second. Well, here's a different type of an equation. So let's consider the equation 5, and then now I'm going to insert a set of parentheses. And when you insert a set of parentheses in math, you essentially change the order of operations. So watch what happens here. List things that have been done to x in the order in which they've occurred. Well, the only way to really understand that is to plug a number in for x. So let's suppose that we plug 1 in for x. And I were to give you this expression. Now, we can talk about distributing this, right? So you can distribute this. But if we were following the orders of operations, the orders of operations tells us that we need to do anything that's inside the parentheses first. So we would really be adding first the 1 and the 12, and then we would be multiplying. So we would be adding, then multiplying. Right? So it changes the order. So we're actually going to add before we multiply, and that's the only time it's going to happen is when there's a set of parentheses. So then you take 5 times 13, and you get 65. Right? Now what we're going to do is we want to solve the equation by reversing the operations. So if I reverse these operations, that means that I'm going to undo multiplication first. So I'm going to divide first, then I'm going to subtract. So watch how this works. Here's the equation. Rewrite the equation down. Okay. So I'm going to divide by the 5 first. Right? So then you get x plus 12. When these 5 cancel out, you're left with the x plus 12 on the left side of the equation. On the right side, 15 divided by 12 is 3. Okay. And then all it's left to do is subtract the 12 from both sides. So I get 3 minus 12 if I have $3, but I need to borrow 12. I need to borrow 9 more. So x equals negative 9. Right? Now, let me just show you that you actually could distribute. I mean, talk about distributing. So I could take this equation and I could distribute the 5. I end up with 5x plus 60 equals 15. And what you end up with distributing is you end up with some pretty big numbers to have to work with. And the bigger the numbers are, the better chance there is for making a mistake. Right? So what this strategy gives you is it gives you an opportunity to look at the problem and make it a little bit simpler to solve. It's all about being efficient. Right? So that's example number 2. And example number 3 is just going to give you a couple more models of this situation. Keep in mind, this only works if you have a number outside of parentheses. Right? So now look at this one. If I were to think about distributing this one, now I've got a negative number out front, and then you've got to remember what happens when you distribute a negative. That's a mistake that can be made. So what I'm going to do is I'm going to divide the negative 4 first to both sides. All right, so I'm left with x minus 7. On the right side, I have a negative divided by negative, which is a positive. All right, so look what happens. These numbers are easier to work with. All right, so now all I have to do is just add 7 to both sides. And this is what we were doing in Fast and Furious the previous couple days. So, and this comes 16. Right. See this one. This one, if you distributed the fraction, then you're going to end up with numbers that might not work so well. So maybe it makes a little bit more sense to divide the fraction out. And this method doesn't always work, so don't think that you can do this every time. It might be easier to distribute, but in this case, I'm going to divide by 2/3. Right? Divide this by 2/3. Right? But if you remember, so you're left with x plus 8 on this side. On the right side, this is really 10 over 1 divided by 2 over 3. Okay, so we have to KCF. Keep, change, flip. 10 over 1 times 3 over 2. 2 goes into 2 once, into 10 5 times. So you get 15 on the right side. Okay, so then you subtract 8 from both sides, and you get x equals 7. Right? So what you're going to do is you go ahead and you can pause the video, and you can work on the rest of these problems, and when it's all said and done, you can unpause and you can check, and then give the challenge problem a try. That would be interesting to see if you can come up with that one. So go ahead and hit pause now. Okay, and we are back, and you can see starting with this problem here, divided out to 6, and then I'm left with a 3x minus 6. So this actually turned into a 3-step equation, so I had to divide the 6, and then add the 6 to both sides, and then divide by the 3, and I got x equals 5. All right, but I just want to keep in mind, there's a different color here, what would happen if I distribute? If I distribute it, I'm going to end up with 18x minus 36 equals 54. What makes that problem pretty tough. All right, so then here are the rest of these. You can see, you can go ahead and check them over. A is 14. You can see the work that I did. I showed every step that I did. This one here, when I divide by the 1/3, it's the same as multiplying. I had the KCF, and I already got the sign. It was negative times a positive, so I knew it was a negative there. All right. Now the challenging one, I'm going to go over that one in class. So good luck, work hard.